Now, from this sort of basic contingency table of proportions and percentages, people often want to ask about relationships between these two categorical variables. So in particular, you might ask, well, we want to know if upper class passengers, are they more or less likely to survive than lower class passengers? To put it another way, we want to know the percentages conditioning on particular values, because so far we know the overall percentages and we know the percentages for particular combinations, but we want to condition on some set of values and calculate the percentages that way. So the key point here is that often the questions you want to ask and answer from a contingency table involves conditioning. And again, this is why contingency table is called a contingency table, because often you want to condition or you want to say things that are contingent upon the values of another variable. So for example, a question that we really want to ask is, among those who survived, what percentage were in the lower rather than upper class? In a similar way, but in a distinctly different way, we might condition on passenger class. So you might say, among those who were in the upper class, what percentage survived? So let's look at a contingency table in which we're conditioning on survival. What we do is we divide the cell counts by the corresponding total for each category of the survival variable, and then we multiply by 100. This will give us the percentages conditional on survival. So you can see that we have the total for this survived category. So we have 618 people who did not survive and 427 people who did survive. And when we divide each cell by its respective column total, we get these percentages. So you can see that we have these different percentages conditioning. Now, to really look at this, it's useful to look at particular cells and understand how to interpret it. So for this cell, we divide 369 by 618. 369 is the number of counts or observations for those in the lower class and in those who did not survive, and 618 is the total overall of those who did not survive. And this percentage will tell us among those who didn't survive, 60% were in the lower class. In a similar way, we know that 24% were in the middle class among those who didn't survive. We're just taking the cell counts for that for a particular cell, and we're dividing by the total number of counts of people who didn't survive. To give another example, we know among those who didn't survive, 17% were in the upper class. And again, among those who survived, 31% were in the lower class. Among those who survived, 27% were in the middle class. And among those who survived, 42% were in the upper class. So when we condition on survival, we can conclude that among those who didn't survive, most, in fact, were in the lower class. As well, among those who did survive, most were in the upper class. So this suggests some kind of relationship between surviving the Titanic and one's passenger class. Now, a sort of different approach is to condition on passenger class. What we'll do is we'll divide the cell counts by the corresponding total for each level of class and then multiply by 100. So this is just sort of converting from counts to percentages. Let's go through a few examples. What we'll do is we'll take the cell count for this particular combination, which is 369, and divide it by 500. Okay, and that is just the total number of observations overall in the lower class, the number of passengers in the lower class. And this will tell us among those who were in the lower class, 74% didn't survive. So conditioning on class, we know that 74% did not survive among those in the lower class. Among those who were in the lower class, 26% in fact survived. Among those who were in the middle class, 56% didn't survive. In a similar way, we know that among those who were in the middle class, 44% survived. And then again, among those who were in the upper class, 36% didn't survive. And among those in the upper class, 64% survived. So conditioning on class also suggests a relationship. We can conclude that among those in the lower class, so conditioning on that particular value of passenger class, most people did not survive. And again, among those in the upper class, most survived. So both of these sort of conditioning events suggest a relationship. We can say that passenger class and surviving the Titanic are related to each other. The way to really think about this is that since the percentages for survival are contingent or conditional upon passenger class and vice versa, these two variables are in fact not independent. If these two variables, passenger class and surviving the Titanic, were independent, then the percentage more or less of surviving would be the same for all passenger classes and vice versa. So we have this relationship, and when we talk about this relationship, it's also useful to kind of talk about distributions. A distribution is simply the arrangement of values of a variable showing their relative frequency, meaning the proportions are percentages. So we think of distributions all the time. So suppose you order a large pizza, you're with your friends, and you have 8 slices on the pizza, and you have to distribute these slices among your 3 friends. So when you make this sort of distribution, you can talk about a distribution that is unconditional or marginal, joint, or conditional. So when we look at these contingency tables, it's useful to talk about it in a way that references the idea of an unconditional, joint, or conditional distribution. So here's an unconditional distribution of class that we've highlighted. And here's the unconditional distribution of surviving the Titanic. The joint distribution is given by the particular cells, and this adds up to 100. Conditional distributions are given here. The distribution of class conditional on not surviving, and then we also have the conditional distribution of class conditional on surviving. And then we also have conditional distributions of survival. So when we condition on this particular passenger class, we have this distribution of surviving. And then we also have a conditional distribution of survival, and another conditional distribution of survival. So the whole point about these distributions is that it's another way to talk about a contingency table. The key points for this part in our discussion of categorical data is that contingency tables can be used to examine the relationship between 2 categorical variables. When there's a relationship between 2 variables, we say that the 2 variables are not independent. And finally, distributions can be talked about in a way of being unconditional, joint, or conditional. And that concludes our discussion on categorical data as it relates to contingency tables.